All right, here we go. This is going to be my second attempt at 7.2 as I forgot to turn on the microphone yesterday. So here we go. Sorry for the delay. This is section 7.2. We are graphing exponential decay functions. So very similar to section 7.1, which we just spent the last 2 days on. But we are switching gears from exponential growth to decay. So emphasis on the word decay here. We're still looking at an exponential function in the form y is equal to a times b raised to the x. And now here, this is what you really need to appreciate, is for exponential decay that the growth factor, and now we actually call it the decay factor, is a number less than 1 greater than 0. Here I'll make up an example. Y is equal to 2 times 1/2 raised to the power x. That is exponential decay. The 1/2 is the b. Realize that this number doesn't make any difference. It could be 2. We could put a negative here. That's not what we determine decay with. Decay is that the number that's being raised to the power x is now less than 1 and greater than 0. Right? So there you have it. And this number is called the decay factor. And for exponential growth, like if this 1/2 had been 3/2, that would be growth, and that would be then called the growth factor. Here is our parent graph, right? Very important that we start off just with the very basic graph, and notice that this graph has kind of the same shape, but exponential growth went low and increased and grew, and here we're decaying. So we start high and moving from left to right, we decay down to the asymptote, which is still going to be y is equal to 0 for the parent graph. Of course, we do any vertical shifting, that'll change. We always go through 0, 1, and then we go through 1, whatever the growth factor is, that point. So those are our 2 points. Our domain is still all real numbers. Our range for the parent graph is y is equal to, or excuse me, y is greater than 0. So let's go ahead and try to do a graph. So again, I would really like you to start all of these graphs by starting and saying, let me at least recognize that this is an exponential function. How do I do that? Well, I see that the variable x is an exponent. That's pretty much step one. Again, we are in that chapter, so if you forget to do that, not a big deal, but if you felt on the mid-year exam that you were kind of unsure of what function you were dealing with, I would really push you to now, as we learn more functions, to really spend the time to identify and be able to recognize this as an exponential function. Secondly, we should look at the b value, and notice here that 3 over 4 is 0.75. It's less than 1, greater than 0. So we are exponential decay. We expect this graph to decline, if you will. We need to plot 2 points, and so we're going to use the point 0 for x. When this will turn 3/4 into 1. 1 times -2 is -2. And when I plug 1 in for x, I should get 3/4 times -2 will give me -3/2, right? The 2 and the 4 would cancel to 2. And so there are my 2 points. Let's go ahead and plot those. 0, -2, 1, -3.5. And again, amazing that we can look at these 2 points, and you should be able to say, hey, that's exponential decay. I'm approaching the asymptote, y equal to 0. And you should have a graph that looks, again, decreasing. Why is it? This first example is aggressive with the negative, right? We were talking about decay looking, the parent graph like this, and so because of the negative, we flipped it. Nice job. And here we go, right? This is everything. Well, not everything, because we don't have a negative in front. But we are including a horizontal shift here. This x minus 1 is the horizontal shift. All your x values will be increased by +1. And then this +1 here is a vertical shift. I personally love, right now, just putting in my dashed asymptote. Just helps me with my graph. And I can do it just by looking at the equation. Again, we should have started, sorry, I was so excited about the horizontal and vertical shift. We should start and say this is an exponential function. X is an exponent. And looking at 3 over 5, that is a number less than 1, greater than 0. So we are in exponential decay. So I'm expecting my curve to decay down. Right. So first thing we should do is plot a point without the horizontal and vertical shift. So that's just this base, equation here. When x is 0, I should get 2 for y, right? 3/5 to the power of 0 is 1. 1 times 2 is 2. And then when I plug in 1, I should get this 3/5 becomes 3/5. Times 2 should give you 6/5. And then we translate. We're going to, all the x values, x values are going to increase by 1, and all your y values are going to increase also by 1. Your note sheet's so nice. They did the x values for you. What a nice note sheet. 0 plus 1 is 1, and 2 plus 1 is 3. And then for the second point, 1 plus 1 is 2, and 1 plus 6/5 would be 11/5. Hopefully that's okay with you, right? The asymptote is the line y equal to 1. Let me hold on the domain and range for a second. Let me go ahead and graph here. 1, 2, 3. There's 1 point. Oops, 1 point. Make it nice big. I caught it. And 2, 11/5. 11/5 a little bigger than 2, just slightly, and approximate. There we go. And it's exponential decay, so I decay through, make kind of curve. Sorry, it's a little tricky on this electric pen, but that's pretty good if you think so. Domain here again is all real numbers. That's pretty much always consistent for all exponential functions. And now the range, I would look at this and say that's y greater than 1. A nice job. So I think it's time for you to try 2 problems, and please do just take a second here. Even if it's a minute or so, if you could think about how to graph these. This, again, exponential function. 4/5 is the decay. You need 2 points. With the negative, it should be flipped. This second one, you're doing a horizontal shift, a vertical shift. Don't forget your asymptote's going to shift, right? And if you could state the domain and range for each of them when you're done, that would be great. Go ahead and hit pause, and when you're ready to see the answers, they will be coming at you. And there are the answers, nice ones from the book. So the first guy here, again, I expected to see this graph. You might not have this slow decay. You could have, tried to get to that asymptote within your picture, and that's fine. But you should have plugged 0 in for x, got -2, plugged 1 in for x, and got -8/5. Domain and range, all real numbers, y less than. Be careful with the less than, right? Make sure you wrote y less than 0. And here we've done our shifting. So this is the, they like to show the sketch before shifting points. I don't really do that. Your final graph here, notice the factor of 2. So your asymptote should be, right around -3. And then the 2 points shifted, right? Your 0, 3 was subtract 1, subtract 3, and you got this point. And your 1, 2 should have come out to 0, -1. Nice work. So we have a word problem, right? We are going to do exponential decay word problems, and so the decay formula here, you might want to put a nice big box around it. Again, I will provide you with the formulas on the quiz and the test, and they're on the mid-year, but you should be able to know how to use the formula. So this A is the initial amount, R is a percent decrease, and I shouldn't probably say percent because you should turn this to a decimal. So it is your how much you're decreasing. T is time. So in this example, nice example, right? New television costs about $1,200. The value of a television decreases 21%. I'm surprised how little it is. I think it probably decreased even more than that. But whatever, it's a word problem. Write an exponential decay model giving the television's value y in dollars after t years. And then it says, hey, can you estimate the value after 2 years? Can we graph the model? And then can we use the graph to estimate how long it'll take until your television is only worth $300. And this guy is super interesting to me, and we'll talk about that in a sec. So you should say the initial amount here is 1,200, right? And again, this decimal of, this percentage of 21% is written as 0.21 as a decimal. So your equation should look like 1,200, right? 1 minus 0.21 t. And then you should simplify this equation, 1,200, and 1 minus 0.29 is 0.79, minus 0.21 is 0.79, and there you should feel good, right? This 0.79 is a number less than 1. This is exponential decay, and we are expecting that because that's what the word problem said to us, right? How would I figure out what the television is worth in 2 years? You'd need a calculator. I don't have mine with me. I'm going to look at the answer. And it says here that the television after 2 years is worth only $748.92. I like my answer because it is quite a bit less than 1,200, right? With a decrease of 20%, 21% is good. I use the graph. Here's the solution. So they plotted 2 points. How much your television's worth initially, how much after 1 year. You could also have plotted the 2 years, at 750 approximately, right around here, and you get a nice exponential decay. This model, by the way, your television will never be worthless. Pretty neat, right? This asymptote here, your television, even after 1,000,000 years, will have some value. It'll never actually come to zero, which is kind of a fault of the equation, but nobody cares how much their television worth after 1,000,000 years. How do I figure out how much my television worth how do I figure out how many years it takes? So here's the algebraic equation. How do I solve this? And hopefully you're still watching the video and really, we'll spend a second here or two thinking about how algebraically we solve this. And you should be pretty frustrated, if not upset. You've taken a lot of years of algebra and we don't know how to solve right now for this variable t. You can't divide off, you can't multiply, can't subtract. All the techniques you've used before, hey, let's square both sides of the equation, doesn't work. Let's raise it to the power 1/2. All the tools you've had so far, it doesn't work. So what the book has said is, hey, can you just estimate it from the graph? So here, 300, it looks like in about 6 years. And we will learn how to do this, how to solve this equation algebraically in the second half of this chapter. I look forward to seeing you guys on Monday. Have a great weekend.